Hey everyone, so now that we know how to multiply radical expressions, we're going to take a look at dividing radical expressions. We're going to be looking at level 1 questions today, which are pretty straightforward and easy to follow as long as you know your perfect squares and you know how to simplify radicals. So if you don't know how to simplify or you don't feel comfortable, definitely review that before you take a look at this lesson. So let's take a look, dividing radical expressions. When dividing radical expressions, divide radicands. Remember, a radicand is the number under the radical symbol. Then simplify if needed. You don't always need to simplify. If you can't simplify, you can't simplify it. But if you can simplify it, you have to simplify. So let's take a look at this example. Express in simplest radical form. And we have radical 20 divided by radical 2. So the first thing we want to do is divide these radicands. Divide 20 and 2. So I'm going to just circle those in red. No. Okay, so I'm going to circle those in red. So we're dividing 20 and 2. And when we divide that, we get radical 10. Now, is there a perfect square that can go into 10 that is bigger than 1? No. So this is our answer for this question, radical 10. We could not simplify, so we're going to leave it alone. But it's pretty straightforward. You divide your radicands and then go from there. Let's take a look at another example. Express in simplest radical form. Now we have radical 90 divided by radical 5. So I'm going to just circle my radicands. That's what we want to divide here. So when we divide that, we get radical 18. So then the question to ask yourself is, okay, can I simplify this radical? Is there a perfect square other than 1 that can go into 18? Hopefully you recognize, yes, 9 can go into 18, and 9 is a perfect square. So we're going to separate that out, where we get 9, and it's 9 times 2. Remember, write your perfect square first, so when you simplify, you're always going to have your coefficient in front. Now, the square root of 9, hopefully we recognize those because we know our perfect squares, is 3, because 3 times 3 is 9. So this becomes a 3, and then we just bring down that radical 2 because we cannot simplify it. And that is our answer for this question. So we divided our radicands. 90 divided by 5 is 18. Found the largest perfect square that went into 18, which was 9. Separated out because 9 times 2 is 18. Perfect square of 9 is 3. That goes in the front. Okay, let's take a look at another example. So here we have expressed in simplest radical form, the square root of 98 divided by the square root of 2. So we're going to divide those radicands before we do anything. Divide them out. And then 98 divided by 2 is 49. Now 49, is it a perfect square? Is there perfect squares that can go into it? The answer is this is a perfect square. What number times itself gives you 49? The answer to that is 7. So rather than splitting these into two radicals the way we would if we were simplifying another non-perfect square radical, the answer to this one is just the number 7. Because the square root of 49 is 7. Not radical 7, not radical 7 times radical 7, just the number 7 in this case. And that happens sometimes because when you divide, you can get a perfect square. And when you find the square root of a perfect square, you get it's square root. All right, let's take a look at one more example. We have the square root of 384 divided by the square root of 4. So let's start by dividing our radicands. 384 divided by 4 gives us 96. So when we divide that, we get 96. Now, hopefully you have your perfect square list ready and available so you can see which perfect squares can be divided into 96 and you start doing that division. I do process of elimination. Okay, can 36 go into it? Can 49 go into it? Can 25? So once you do that process of elimination, you'll see that the square root of 16 is the largest perfect square that can go into 96. So this becomes the square root of 16 and 6 because 16 times 6 gives us 96. Now the square root of 16, what number times itself gives you 16? The answer to that is 4. So our answer to this one is 4 radical 6. And we can't simplify radical 6 because other than 1, there's no other perfect squares that can be divided into 6. So the takeaways from this lesson is divide your radicands and then check to see if you can simplify that radical. If you can use the largest perfect square method or the other method where you just divide by a known perfect square, as long as you know to keep simplifying it until you have a radical that you can't simplify anymore.